Hello, this is Geometry, Notes 12-6, Surface Area and Volume of Spheres by Mrs. Moslick. Go ahead and do the warm-up. Pause the video. When you're done with the warm-up, put your pencil down, pick up your red pen, and then unpause the video to check your work. Okay, who got the answer of 3? No, that's not right. X turns out to be 3, but that has not answered our question. So we need to now know, since X is 3, because 3 cubed is 27, so X is 3. Now go ahead and replace X with 3, and now answer the question. Pause the video. When you're finished, go ahead and resume the video. And the final answer is indeed 12. The reason for that is you replace all of your x's with 3. Let's go ahead and move on to the next warm-up. Okay, go ahead and do the second warm-up. Pause the video. When you are done with solving this problem, put your pencil down, pick up your red pen, and then play the video. Okay, raise your hand if you actually drew a picture of the triangular prism. I should see more hands up than that. Okay, let's try it again. So go ahead and with your red pen, draw your prism, your triangular prism. Now, raise your hand if you have a triangular prism written on your paper. Oh, good, all of you. Good job. Now go ahead and highlight the bases and with your red pen, identify the height. Okay, you really can't do this problem well unless you actually draw the picture. So now we have volume of the prism is area of the base times height. That is required that you give me the formula. The next step that is also required is that you write down the formula for area of the base, which is 1/2 base times height. The base is a triangle. It's clearly shown it's the yellow piece. The height of the triangle is different from the capital height of the object. Then we know that the volume is 1380, and it's a simple algebra problem where you are replacing your base with 8, your lowercase h, the height of the triangle, with 15, and we just need to find height. If you did not figure this out yet, go ahead and pause the video, finish it up. And the answer is 23 centimeters. B. Raise your hand if you originally got that before having me explain it. Oh, good. Most of you guys should have gotten that. The reason for that is if you did your homework on the last section, you should have been able to get that. Great. Let's move on. Okay, so this last section for Chapter 12, Notes 12-6 on surface area and volume of spheres. We are talking about surface area of a sphere is 4 pi r squared. Volume of a sphere is 4/3 pi r cubed. We derive that using calculus. Here's a true story. I was on the plane to a math conference in Philadelphia. On the way there, a man sitting next to me asked me, "How do you derive the formula for volume of a sphere?" I looked at him, I laughed, and I said, "Are you serious?" And he said, "Yes." And I proceeded to do the calculus on a napkin, and it was so much fun. So rewarding for him and satisfying for me using some calculus, deriving the volume of the sphere. So we won't derive that here. That's something to look forward to. At this point, just identify that surface area is square units, volume is cubed. That's how you can remember that in your volume of a sphere you have cubic, and for surface area of a sphere you have squared. Also, when you see a 3, you have a 3. That's a way to memorize it. This is not appropriate to really understand the concept, but for our video notes, because we are not meeting, so I can't show you extra stuff right now. Just use these tips to help you remember these formulas. Okay, now when you're dealing with the radius of a sphere is the radius of the great circle. The great circle is the plane that intersects or slices the sphere through the diameter, so it's the biggest radius of your sphere. That's the radius we're going to be dealing with. And again, we'll use these two formulas to answer the next couple of questions. Okay, example 1, find the surface area and volume of a sphere with a great circle that has area of approximately 32 square feet. So first of all, we have to find out what the radius of this sphere is. So we're going to start off with area. Area equals pi r squared. After we're done with finding the radius, then we will find the surface area, and then we will find the volume. So 3 parts to this problem. Again, let's start with the area. So the area is 32. That equals pi r squared, and again we'll try to find the radius from this, so divide both sides by pi and solve for r. So we have 32 over pi equals r squared. Take the square root of both sides. When you take the square root of the left side, put plus or minus. But radius is just a positive value. It's the distance from the center of a circle to a point on the circle. So this is our answer. It's approximately, put that in your calculator, square root 32 divided by pi, enter, and you get about 3.192, but we won't use that. We're in honors geometry, so we'll use the square root of 32 over pi for both the surface area and volume. Okay, so surface area formula is 4 pi r squared. Again, you derive that formula using calculus. It's really fun. 4 pi times 32 over pi, and yeah, I'm just using the r squared answer, so I'm just putting this into my r squared. No reason to take the square root and then square it. So what we have here is the pi's cancel, because we have 4 pi times 32 divided by pi. So just multiply that out, and you get 128. So we have 128 square feet for the surface area. Let's move on to the volume. Volume of a sphere is 4/3 pi r cubed. We are going to use the r, which is the square root. Be really careful when you're using your calculator that you're going to end the square root with, after the square root of 32 over pi, close parentheses, then close another parentheses raised to the third. Go ahead and put that in your calculator. So we have 4 divided by 3 times pi times parentheses square root 32 divided by pi. Now be careful here. After divided by pi, put another end parentheses, end parentheses, and then raise to the third. Enter. When you put that in your calculator, it doesn't say how many decimal places, so let's round to 3. I get 136.172. Oh, okay, so I see a couple of you guys didn't get that, so let's go back. Okay, so clear out your calculator. Let's try it again. So put in 4 divided by 3, and then you can just put pi or times pi, parentheses, square root, and it should automatically give you parentheses there, 32 divided by pi, close the parentheses, close another parentheses, raised to the third, enter. Okay, now you guys got that? Excellent. So 136.172, and that'll be our final answer. So our final answer is 136.172 cubic feet, and let's go to the last problem. The last problem is a challenge, and it's a little fun. Actually, it's a lot of fun. Last problem of the entire notes for chapter 12. Okay, it says find the surface area and volume of a hemisphere that has a great circle with circumference 18. So first of all, let's just figure out what the radius is. So circumference equals 2 pi r. They tell us that the circumference is 18. Now let's remember, when you are putting this in your calculator, you're going to take 18 divided by 2 divided by pi. So when you put in 18 divided by 2 divided by pi, you should get about 2.865. If you're getting a radius that is bigger than the circumference, you did something wrong with the calculator. It's not the calculator's problem or fault. It's not your calculator that's broken. It's you. So let's again put that in your calculator, right? It's 18 divided by 2 divided by pi, or 18 divided by parentheses 2 pi. Well, nevertheless, we'll put in our formula 18 divided by 2 pi, or 9 divided by pi, as exact. So let's go ahead and start with the surface area. So surface area equals, now, stay with me here, you guys. This is the last lesson. You can do it. Think about a half of a tennis ball. If you cut that in half, you have a bottom piece. So surface area is going to be half of the surface area of the sphere. So it's 1/2 4 pi r squared. However, do you also know that if you had to color that half of the tennis ball, that would be, actually a tennis ball is probably not a great example. A better example is probably a foam ball. I actually have one and I would show it to you in class, but we're not in class right now. So think about a foam ball. You cut it in half and now you want the foam ball to be all, let's say, orange. So that means you would have to color the outside rounded part and you would have to color this base. And let's say you want it all orange. So not only are you taking half of the surface area of a sphere, you're also adding a area of a whole circle. So we have surface area equals 2 pi r squared plus 1 pi r squared, and therefore our surface area of a hemisphere is 3 pi r squared. Please don't memorize that formula. I will want you to give me these 3 steps before you just write down 3 pi r squared. There's no reason why you would memorize 3 pi r squared. Just think about it conceptually. So I would want the 3 equations. I'm taking half of a sphere, surface area, plus the base part of that hemisphere, which is a circle. Okay, so now we have our formula, and we have surface area equals 3 pi times r squared. Now, r is 18 divided by 2 pi, or 9 divided by pi, and then we'll square that. Go ahead and put that in your calculator. It doesn't say how many decimal places to round to, so let's round to 3 decimal places. So 3 pi parentheses 18 divided by 2 divided by pi, close parentheses, squared. Okay, and you should have gotten 77.349. If you did not, again, what you would put in your calculator is 3 pi parentheses 18 divided by 2 divided by pi, close parentheses, raised to the second. Okay, last part, we're talking about volume of a hemisphere. Very easy. It's just thinking about that foam ball that I cut in half. I actually did cut it in half. I wish I could show you it. Nevertheless, it's 1/2 times the volume of a sphere, 4/3 pi r cubed. And now just plug in your particular numbers. But I wouldn't do that yet. I would just simplify this. This is 2/3 pi r cubed. Again, don't memorize this formula. You must give me the original idea. Is I'm taking half of the formula for volume of a cube, just like for surface area of a hemisphere. Show me that it's half of the surface area plus the base area, which is a area of a circle. Anyways, back to our problem. Go ahead and in our equation, we're going to replace the r with 18 divided by 2 pi, or 9 divided by pi, and then now cube it. Okay, put that all in your calculator. You should have gotten 49.242, and that's cubic feet. That concludes our entire notes, video notes, chapter 12 on surface area, lateral area, volume of cones, cylinders, prisms, pyramids, and spheres. Hope you've had an enjoyable time and have fun doing problems with all these concepts. Make sure you are showing formulas and not just memorizing them, but understanding them. Have a great time. And if you have any questions, make sure you just go back to these video notes and go to the section that you're confused on. Have a great time. Bye-bye.